Hello everyone. So this is what we are going to talk about today. We are going to do a serious deep dive into the foliage and grass system that we have implemented and how to get rid of spikes and how to achieve smooth performance with 120 fps across the infinite uh, terrain that we have developed. So this is what I'm talking about. Let me speed up the game a little bit so we can see easily. Now you see, if you pay attention to the bottom left, you can see the unit graph where you see spikes. So these spikes are related to mostly the spawning of foliage. We already have a little bit of a spike for as we generate landscape chunks in the distance, but yeah, let me show that too. But we do need the landscape chunks, but the foliage is something. Foliage is what we are going to focus on today, and how to achieve optimal performance, how to get rid of these spikes that causes this frame stutter. I mean, even with the spikes, we already have 120 fps, and temporarily it drops to like 80 fps, which might be still in a good place to be, but I want to have smooth performance all over the place. And if you are in like a working game, this much of a speed will not be required at all, so this would be already good enough. But if you are in something like a flying game, then of course you need to be you need a much performant system. So how do we fix this? Okay, so we are going to get a little bit technical here. So here we have two separate costs. Before we get into that, let me show you the fixed version of this. So at the end of the video, this is what you would get. Now you see, this is much better compared to before. We don't have a considerable frame stuttering. This is very good compared to what we have before, and even though we have a spike, it is well within our budget. So yeah, okay, now this is what we will have at the end of the episode, and I'm going to explain everything. All right, now back to the problem and how to solve it. So yeah, let's go here. So in our foliage system, we have two separate costs: scattering computation and adding instances. So scattering means which grid points get instances. That means where to spawn trees. This is running on thread pool, so pretty young game thread. So this is never the bottleneck we have. The bottleneck we have is this adding instances. That means we upload the transforms of each instance of the tree that we need to spawn to the GPU. So this runs on game thread, and this is what causing the spike. Now to demonstrate that, here, let me disable the entire foliage system and run the same thing. Now here, now we only have the terrain generation. As you can see, we do get a spike. That's because as we move around in the distance, new terrain chunks are being added, so that we can maintain an infinite terrain. So, but yeah, that is this is well within our budget. You can see, as you can see, we have 120 fps almost always, except a little bit drop when the new chunks are added, but this is acceptable to me. Right, now with the foliage, the spikes tends to be a bit higher. Now this is what triggers the upload. Upload means adding new instances of foliage. So player cross chunk boundary and new chunks enters the range. So for entire new chunks that are within the foliage visibility distance, required new foliage transforms are computed and uploaded so that we can spawn new foliage instances. So this is like if we have 300 trees on 3 new chunks, this is what is causing the spike. Now here, if I open the foliage, you see max foliage distance here, this parameter. I have currently set that to 4. Now to explain that here, let me detach. Now you can see here, we have foliage up to this level. You see in red foliage, but further into the further you don't see red. That means we only have landscape there. We don't have any foliage in further landscape chunks. And as I move, let me move within this wireframe range, you see new chunks are added, and also foliage is added to the chunks that became closer to the player, like that. So this adding new chunks is causing the performance drop, performance spike. So here you see two spikes happening. One relates to, well, it's not always the same, but that's mainly coming from new instances added to the system. So we have two options here: ISM or instanced static meshes, or hierarchically instanced static meshes. So both options have pros and cons, but none of them is going to address the major problem that we have here. So here, if I open, you can see either use HISM, or if you disable this, it will use ISM. But if you enable Nanite, then these wouldn't matter. The system already supports Nanite, by the way. So anyway, so the difference is, if I am using HISMs, we have this BVH tree that stands for bound volume hierarchy. So this is required for GPU occlusion or distance calling. This is very good when you have thousands of instances across a large area that would enable you to render a large number of trees. But this calculating this tree calculation, this data structure calculation, this is expensive. And for a game that you only have to build this once, when you have a fixed terrain, this is very good. But in our case, we have a terrain that is created as we go, so this is not very good in our use case. And so that's one problem with HISM. But with ISM we don't have that, but still we have this add instances. This has this upload cost with a big O and complexity. Well, that simply stands for the cost grows proportionally to the number of instances being added. Here we don't have that tree rebuilding overhead with ISMs, but we would still see the spike. Let me show that here. By disabling this, we would see a little bit of a improvement, but not much. We are still going over the budget, this 70% range. Right, see. So this also depends on how many tree instances that you need to add. It also depends on the shape of the landscape as well, because we have some constraint where that directs where foliage can appear, like slope constraints. Okay, so HIMS, as I said, HIMS pays off. In this scenario, this is the system used in Unreal Native Foliage system. And for a fixed terrain, no need to rebuild the PVH tree. And in our case, this does not work well, because as we add new chunk foliage, we need to rebuild the BVH tree. So here is a comparison of everything. In short, if you are using Nanite, always use ISM. Right, now the difference in grass system. So I should rename this later on. Instead of calling grass, maybe we should call something else, because we can use the same system to spawn trees as well. But here the difference is the foliage system is chunk driven. So player crosses boundary, full chunk loads, and that causes spikes. And grass is radius driven. Player moves 500, update grass like 500 centimeters. It only add instances to the moved range. So only radius edge instances added are removed. Because of that, it doesn't cause spikes. Now let me show that in action. Let me re-enable foliage, grass, and this is actually the grass on lands. This is the pine tree. Let me show that. This pine tree, and this one is actual grass clump. This. So pay attention to the pine tree, and this is, I will come to this later on. So here you see these are the settings I have, and here also we have clustering behaviors and everything. And so I'm going to use that to spawn trees, not the foliage system. Now see what happens. And there is a caveat to this as well. So here you see the spike is really coming only from the landscape generation, not from the foliage. It's perfect. So yeah, so what's the catch? So here you see, let me slow down. Oh, slow down. Slow down. Yeah, there are no collisions here. For grass, it's totally fine, but for trees, we do need collision. We don't. So it's not that we can't enable collision. We totally can. So here I have the option enable collision. And now see what happens. Performance get tanked. See? It drops seriously. Now, this didn't happen. So if you don't move, it goes back to 120. But if you do move, performance crashes. So this, even though with the foliage system, we already had collision, but we did not have this problem. The reason is in the grass system, as the player moves, the instances are added and removed around the player depending on the radius we have defined. But in foliage, even though we add and remove, that only happens when player cross the boundary of a chunk. A chunk means one of these. See, these are chunks. So that does not happen often, but with the grass system, this happens more frequently. And when you have enabled collision, it causes all physics bodies related to grass, this foliage system, destroyed and recreated. And when this becomes unbearable when this happens often, just like in this case. So because of that, it causes a massive performance problem when we use collision with the grass system. But there is a solution to this. So now I'm going to disable collision for this one, this ISM pine. So again, let me show you. Oh, we need to restart. Again, now we have perfect performance without the collision. So to fix this is what I did. Here, I have duplicated this same pine grass foliage asset, and then here I have enabled collision. I kept all the parameters same except this radius. This is now only set to 10,000, which is 100 meters in Unreal units. So here, now as you can see, we have enabled collision. And if I add this also into our grass, now we would have the best of both worlds. So this is the difference. Now here, see, now we do have collision. We can't move through the grass, through the trees. And also, we don't have those spikes as well. We have good performance as we fly over. But as soon as I go closer to a tree, I would get collision. Now what happens is this. Since I am using this duplicated asset, and since all other parameters are identical except the grass radius, that this means the visibility radius. So because the system is deterministic, so in all the places where I already have these pine trees, I spawn a collision enabled pine tree mesh only within a small range. So because of that, we get collisions only around a limited area around the player. So this causes a minimal effect to the physics calculations related to the collision system. Because of that, we get great performance. So that's the trick. Oh, I forgot about the presentation I prepared. But yeah, I have summarized those things that I have said in these slides. So this near far collision pattern, this is what I explained now. And yeah, so this same grid size, same world position, because of that you would not see any Z fighting, but you can if you want. Maybe I need to polish this system a little bit instead of having to create two assets on the same type. Maybe I should embed that as just an option into this same asset where you can enable collision for a limited radius. I would do that in the next update, but this would be what's happening under the hood. And also you can maybe keep the instance invisible, the collision enabled instance invisible. So it's just like a alias object or only for collisions. But yeah, that's the secret. And these are the pros and cons of foliage system and grass system. Foliage system, simple setup, one data asset, biome routing built in, and clustering, high slope filters. We have all these things in grass as well, by the way. Perlin regulation, ISM, HISM toggle is also there. The cons are chunk boundary patch spike, the spike that we had, and rebuilds on every chunk load. Not suited for dense cover, of course. HISM plus Nanite would be a waste. And with the grass system, yeah, I don't want to read the slide, you can see. So yeah, this is the summary of things I need to talk about today. And this is when to use which system, foliage system. for sparse props like trees, boulders, ruins, signposts, things that you don't have a lot of instances. But for trees, maybe depending on how many trees that you have, but but as you in this, according to the example that I demonstrated, for trees also grass is better, but yeah, it depends on how dense you need to be. And yeah, as of now, you do need to set up these two assets with near far collision separation, but I will integrate this into the grass asset itself in a future update. And both do work with Nanite. And in both cases, I can select the biome. This is the grass. This is the foliage. Here I can select the biome. Okay, so yeah, thanks for watching. As always, updated project files will be available here for download in my Patreon page, and also it is available in Fab as well. But you can access project files if you choose to become a member, so feel free to check it out. I'll leave the link in description below. And here is the full playlist where we implemented runtime terrain generation system from scratch. This is not the same system you saw today, but if you want to implement a similar system by yourself, this tutorial would give you some good a good starting point. Actually, this is already we have a working version here as well. So yeah, I'll leave the link to this as well in the description. So yeah, thanks for watching. See you in another video, and don't forget to like and subscribe. Goodbye.